All right, here are your notes for ratios and proportions. We're going to start off by defining a proportion, which is a statement that two ratios are equal. Two ratios are equal. Okay, so a ratio is like two fractions, basically, set equal to each other. This is what we call a proportion. And so oftentimes you'll see it written as A is to B, as C is to D. And we basically are considering those are two ratios. So one ratio is a comparison of data, and another ratio is a comparison of data, and the whole thing is a proportion. We're going to talk a little bit about ratios in just a minute. An extended proportion, three or more ratios set equal. Three or more ratios set equal. Example might be the fraction 1/3. That is the same thing as 2/6, which is the same thing as 3/9. You would agree that if we reduced 2/6, it equals 1/3, and if we reduced 3/9, it also equals 1/3. So that is what we call an extended proportion, because there's more than just two ratios set equal to each other. Solving proportions is something I think all of you will know how to do already. Basically, you're going to cross multiply, and I think we've all done a lot of this already and should be somewhat comfortable with it. Okay, so the first thing you have to do, I'm going to do the first one with you, is multiply across. So 7 times x is equal to 5 times 12. That is equal to 60. So right now we have the proportion set up, and we've just cross-multiplied, and then we're going to have to solve. Okay, so I'm just going to pause the recording here for a second. Guess I'm not. Okay, so we're going to take the 7, we're going to divide both sides by 7, and we're going to get x equals whatever that answer is when we go ahead and plug that in. All right, so that will equal 8.6. I had to go grab my notes. I left them across the room. Sorry about that. Okay, and part B, we're going to do 4 times y plus 3. It is really, really important when you do this one that you keep the y plus 3 in a set of parentheses. It's really important. It's a 1 unit, and we have to multiply the whole thing by 4. So we're going to distribute the 4 now. 4 times y is 4y. 4 times 3 is 12. And then from this point on, it's just collecting terms on one side of the equation. Think back to Algebra 1. 12 equals 4y. Divide both sides by 4. So y equals 3 for the second question. Y equals 3. Okay. We're going to come all the way across the page over here to do letter C. So again, cross multiply. 20 times z is equal to 5 times 3. So 20z equals 15, and you're going to divide both sides by 20 to get z by itself. When you do that, you can leave it fractionally as 3 over 4, since they're both divisible by 5, or you could give the decimal answer 0.75 if you just did it out on your calculator. Either way, it's perfectly fine. And then again, I'm going to come over here and do D, where I have a little more space. 18 times n is equal to 6 times n plus 6. Again with the parentheses, because we have a binomial and we have to multiply everything by 6. Let's distribute the 6. 18n equals 6n plus 36. Collect all your like terms on one side of the equation, and I get 12n equals 36, and I'm going to divide both sides by 12. N equals 3. Okay, n equals 3. So that's the section on proportions. You're writing two fractions set equal to each other. That's what all of these look like, two fractions set equal to each other, and then you cross multiply to solve. All right, let's move on and talk about ratios. So I'm just going to scroll the page up, and we're going to talk about the ratio problem. Okay, first let's define a ratio. We originally talked about it a minute ago at the top of the page. We kind of said a ratio is a comparison of two quantities. Okay, comparison of two quantities. Sometimes it's written like this, A is to B, and we read the fraction bar as is to. A is to B, or sometimes it's written this way, A is to B with a colon, preferably written as a fraction because we're dealing with math, and most of the math we deal with is a fraction. So what do we use ratios for? We use them to enlarge or reduce things. A ratio is very similar to a scale factor. And so in part A, we're going to talk about the ratio of the width of the photo to, and that's sort of where your colon comes in, so the width of the photo to the width of the poster. And if we look at this description at the top, a photo that is 8 inches wide and 5 3/3 inches high is enlarged to a poster that's 2 feet wide and 1 1/3 inch high. I don't know about you, but I like to have a picture. So 8 inches wide, 5 1/3 inches high, and I'm changing that to a poster that is 2 feet wide by 1 1/3 feet high. Okay? They want the width of the photo, so 8 inches is to the width of the poster, 2 feet. Now the only problem we have here is we can't compare apples and oranges. These are two completely different things, inches and feet. So in my mind I'm going to say 1 foot equals 12 inches. So 2 feet is double that, 24 inches. And I'm going to replace the 2 feet with the 24 inches. So now it says 8 inches is to 24 inches. And I can compare this now. 8 and 24 are both divisible by 8. 8 divided by 8 is 1, and 24 divided by 8 is 3. So we get a ratio of 1/3. That means the poster's 3 times as large as the photo. We can do it again with a second example. This time we're talking about the height of the photo to the height of the poster. So height of the photo, 5 1/3 inches, is to the height of the poster, 1 1/3 feet. So we're sort of running into the same issue we had last time. But first let's just take care of the fraction problem. We're going to change the improper fractions or the mixed numbers into improper fractions. 3 times 5 is 15, plus 1 is 16. So 5 1/3 is the same thing as 16 over 3 inches. And 3 times 1 is 3, plus 1 is 4. So I get 4/3 feet. And I hope at this point you recognize that both denominators are 3. So if I multiply the numerator by 3, the denominators cancel. And if I multiply the numerator of a fraction by 3, I have to multiply the denominator by 3. Those are going to cancel. And I'm left with 16 inches is to 4 feet. Again, apples and oranges, I need to fix it. 1 foot is equal to 12 inches. 4 feet would be 4 times that, or 48 inches. So I'm going to replace 16 inches is to 48 inches, and then both of those are divisible by 16. 16 divided by 16 is 1, 48 divided by 16 is 3, and I get the ratio of 1/3 again, which I hope that if I'm dealing with the same problem, I have the same ratio of its enlargement, or I've made a big mistake and my picture is not going to look proper because it's not been, the width has not been increased by the same amount as the height, and in this case it has, so we're all good. And that is the 7-1 video notes. Go back and listen to it as many times as you need to and catch up. Otherwise, you can move on and start working on your practice page.